Hello friends, today we are going to discuss here Ohm's law and series and parallel circuit. So, let us begin. First of all, we will discuss about the Ohm's law. So, according to Ohm's law, in any circuit, if I current is flowing, then it is directly proportional to the excitation or voltage we have applied in the circuit, as we can see from the diagram as well. As we can see from the diagram that there is a resistance R which is connected in parallel with voltage V, okay, and current I is flowing in the circuit and the direction of current is clockwise. Okay. So, according to Ohm's law, the flowing current I is directly proportional to V. So, we can see I is directly proportional to R और जब हम इसका प्रोपोर्शनल का साइन हटाएंगे तो हमें एक यहाँ कांस्टेंट लेना पड़ेगा. ओके. सो वी कैन सी V is equal to I into R, where V is the voltage and I is the current. And what is R? So, R is constant and it is known as resistance of the element. Okay. So, R इस एलिमेंट का रेजिस्टेंस है. इसके बाद हम देखेंगे सीरीज एंड पैरेलल सर्किट. ओके. As we can see, there are R1, R2 and R3. Three resistance are connected in series and I current is flowing in clockwise direction among all the resistances. So, as we can see here that their voltage V applied and current I is flowing in R1, R2 and R3. Okay. So, as we can see that voltage V is dropping in R1 as well, R2 as well and R3 as well. So, voltage V is divided in R1, R2, R3 with their proportion of R1, R2 and R3, and current I is flowing same in all the resistances. Okay. So, here R1, R2, R3 are resistances, I is current and V is voltage. So, we can write that V is equal to V1, V2 and V3. And what is V1, V2, V3? It is respective voltage drop. It is V1, this is V2 and next this is V3. Okay. So, V is equal to V1, V2 and V3. So, according to Ohm's law, that is V equal to IR. What is the value of V? So, value of V is I into R. So, we will write the voltage in form of current as well. So, V equal to I into R. Here what is V1? Since I is common and V1 is respective of R1 plus I into R2, I into R3. Now, we can take I common from this equation. So, what next? IR is equal to I into R1 plus R2 plus R3. Okay. Now, we can cancel this I from both the side. So, what is final? R is equal to R1 plus R2 plus R3. So, this is the series circuit or series connection of resistance. As we can see that R is equal to directly addition of the all resistances. Okay. Next we will see parallel circuit. So, next one is parallel circuit. Okay. So, let us draw a parallel circuit which is suppose this is R1, this is R2 and this is R3. Let V voltage applied to the circuit and I current is again flowing in the circuit, but we can see at point A the current will divided into three parts, that is I1 here, I2 here and I3 is here. Okay. And voltage V is equal to V will be equal to same in all three resistances. So, here we can write that I is current, V is voltage and R1, R2 and R3 are resistances. Okay. Now, we can write that I is dividing in I1, I2 and I3. So, here I is equal to I1 plus I2 plus I3. Okay. Current is dividing in three part I1, I2 and I3 at point A. Okay. So, again according to Ohm's law, that is V equal to IR, then what is the value of I? The value of I is V by R. So, now putting the value of I in equation 1 we can see. Okay. Now, V by R is equal to, as voltage is same in all the resistances. So, here V by R1 plus V by R2 plus V by R3. Okay. Now, we can take common this V from both the side. So, what next? V by R is equal to V into 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay. We can cancel this V from both the sides. Okay. So, what next? 1 upon R is equal to 1 upon R1, 1 upon R2 and 1 upon R3. Okay. So, this is all about the parallel connection of resistances. Okay. So, what we have seen that Ohm's law, series circuit and next parallel circuit. Okay. Thank you.